Hi guys, my name is Asma, and if you all remember in my previous video, we explored the false position method, what it really is, and its Python implementation. Today we're taking a practical step forward by solving an example. By working through this specific example, we'll witness the step-by-step execution of the false position method, gaining practical insights into its mechanics. So let's dive into the example to understand this numerical technique and its implementation. Here's the given example. We have a function fx is equals to x squared minus 4. So let's break down each iteration step by step. We start with the initial interval a comma b, that is 1 comma 3, and we'll use this value to basically calculate the first approximation c1 with the false position method formula. Now the formula for this method is c is equals to a into f of b minus b into f of a over f of b minus f of a. Now let's see what these variables represent. A is the left endpoint of the interval and b is the right endpoint of the interval. F of a is the value of the function fx at the right endpoint a, and f of b is the value of the function fx at the right endpoint b. So we then evaluate f of c1 and f of 1 into f of c1. Since f of 1 into f of c1 is less than 0, indicating opposite signs, we update our intervals to 1 comma 1.75. How did we get 1.75? By putting these values in the given formula. And so we update our interval to 1 comma 1.75 for the next iteration. Now we'll be using the same formula to calculate iteration number 2 and 3. So we calculate the second approximation c2 using the given formula. c2 is equals to 1 into f of c1 minus 1.75 into f of 1 over f of c1 minus f of 1. So our answer would be 1.414. We evaluate f of c2 and observe that f of 1 into f of c2 is less than 0, indicating opposite signs once again. So we update our interval to 1 comma 1.414 for the next iteration. So now a is 1 and we have b as 1.414 for our next iteration. In the third iteration, within the updated interval, we calculate c3 using the same formula. c3 is equals to 1 into f of c3 minus 1.414 into f of 1 over f of c3 minus f of 1, and the answer we'll get is 1.378. Evaluating f of c3, we find that f of 1 into f of c3 is less than 0 once again, indicating opposite signs. So we update our interval to 1 comma 1.378 for further refinement in subsequent iterations. So our a is now 1 and our b is 1.378. This process iteratively continues, narrowing down the interval until the desired level of accuracy is achieved in approximating the root of fx is equals to x squared minus 4 within the given interval. The key is using the false position method formula to calculate c and updating the interval based on the signs of the function values at the endpoints and c. So in conclusion, we've navigated through the implementation of the false position method in numerical computing, understanding its core formula and iterative process. I would encourage you to try solving a similar example on your own, applying the false position method and observing how it systematically narrows down the interval to approximate the root. So thank you for watching, and that is all for this video.